5-6 is our last section of new material, and the concept in it is really simple. So let me try to explain the concept, and I'll show you the theory of why the calculus works the way it does. But if you don't understand the theory perfectly because you're not that visual, still can get the answers right just fine. Anyways, in section 5.6, we're going to be trying to find an area that's between two graphs. Not between like the graph and the x-axis like we've been doing, but physically between two graphs. And so what's drawn on the screen right now are two graphs. The horizontal line it's drawn in blue, but it's not showing up so well. That's the graph of just g of x equals to 2. And the parabola that's drawn in some reddish color, and the colors aren't showing up so perfectly here because of the shading kind of destroying that. That parabola is the graph of f of x equals 14 minus 3x squared. Kind of strange numbers, that 14 minus 3x squared. I wanted the graphs, the calculations to come out nice, and so I had to make numbers kind of play with them to work. So I'm trying to find the area above the horizontal line at 2 and beneath the f of x equals 14 minus 3x squared between x equal to -2 and x equal to +2. This is what this picture shows. The area beneath the function 14 minus 3x squared above the function f of x, g of x equals 2 over the integral from -2 to 2. If I integrate between the function between -2 to 2, if I just integrated that function, it's going to give me the area all the way down to the x-axis. Similarly, if I integrate this function, it's going to give me the area all down to the x-axis. Integration doesn't give me areas between curves. It gives me area down to the x-axis. That's not such a bad thing because we can work with that. Let me show you graphically or pictorially what we're going to try to figure out here. So what I could do is I have this skill. I can integrate the top function, 14 minus 3x squared, the parabola, and I can get the area from the parabola all the way down to the x-axis by just integrating between -2 and 2. And what this integration is going to do, it's going to give me all of the area that I want and a little extra shaded area. Let me calculate the total area here, the area that I want plus the extra area, by just using my calculator. So I'm going to enter this function 14 minus 3x squared in y1. So y equals 14 minus 3x squared. I'm going to set my window so I can see this 14. I imagine I have a standard window right now. I'm just going to take my standard window and make the y max higher than 14 so that I see this nice parabola. And let me integrate. So second calc, the integration from -2 to +2. And that tells me that this whole area is the area that I want, the desired area, plus a little bit of extra, is 40 square units. So what I've calculated is more than I want, but I can't directly write yet, before knowing some theory, know how to get this area in one computation. So let me figure out how much little extra area. So this area right here, I need to figure out how much that is, and I'll subtract it out. So this total area is overestimating the area that I want. So let me figure out the extra area. Well, that extra area is that right there. It's the area between this rectangle that I drew here, between -2 to 2 of that function 2. So the extra area, if I just clear this out enter the function 2. That's what that line, that horizontal line is at 2. And figure out my extra area by going second calc, integrate from -2 to 2. The extra second calc, integrate lower limit -2, upper limit +2. The extra area is 8. This area down here, that's my extra area. So graphically, this whole area beneath the graph all the way down to the x-axis is 40, and the extra area part of it is 8. So my shaded area is 32 square units. The answer to what is the shaded area in my initial graph, it's 32 square units. The shaded area in the original graph, 32 square units. Fortunately, I don't need to go through this process every single time to figure out the area between two functions, because there's a theorem, and it's basically what we just did. The theorem that we're going to use, it says if I want to find the area between two curves over an integral, I just take the integral of the top function minus the bottom function. In this particular integral, I'm integrating between these two curves here, I'm finding the area between these two curves. The function that's higher, or the top function, is the 14 minus 3x squared. The function that's lower is the 2. If I just take these two functions, the 14 minus 3x squared function, and subtract the 2 function, and integrate those in one integral, it's going to give me the net area without having to do all these separate integrals. I'm going to integrate over the same -2 to 2, the top function in the picture minus the bottom function in the picture. This is finding the area all the way down. This is subtracting out the excess area. Let me show you that this will give me that same 32 that I got when I calculated the area separately. So y equals clear 14 minus 3x squared minus 2. And integrate. Second calc, go down to option 7, lower limit -2, upper limit +2. Bam, the area is 32 in one computation. That's what we're going to do in this section, is just with one single computation, find a shaded area between two curves. And it's as simple as getting a graph of the two functions over the interval, figuring out which function is above and which function is beneath, do the interval for my, the values of x for my definite integral for the numbers, and just subtract the top and the bottom function. So let me show you another picture. So I have a picture here. I don't know how well these functions are showing up, but I have two graphs. I have a top graph, which is the function f of x equals x plus 4, and a bottom graph, which is the function g of x equals 3 minus x over 2. Stole this from Google Images. It looked nicer than any picture I could draw. And the shaded area that's drawn goes between x equal 1 and x equal to 4. So I have shaded an area between a top curve and a bottom curve over an interval. How do I find out that area in one step? I form the integral. In this case, the integral is going to go from 1 to 4 because the shaded area starts above 1 on the x-axis, ends at 4 on the x-axis. And now I need to take the top function, which is x plus 4, subtract the bottom function, which is 3 minus x over 2, integrate that with a dx, and I have to be super careful when I'm subtracting. If I'm subtracting and I don't put the entire function that I'm subtracting in a parentheses, then I'm probably going to get the wrong number because I'm going to have a sign error. So this is what I'm going to need to integrate. And the second function, if it's a binomial, needs to go in a parentheses. I could just enter this just like this to find the area, or I could simplify it if I care to. Because My goal is just to first create the integral needed to find the shaded area. Done that, even though it's not simplified. And then find the shaded area. Let me find the shaded area and then show you the simplifying. So make a new y equals. It's got to be x plus 4 minus parentheses. The second function has to go in a parentheses if it's a binomial. Minus 3 divided by 3 minus x over 2. That's my function. Don't necessarily care what the graph looks like. It's not going to look anything like the original picture because I'm netting out the subtracting. It kind of distorts the picture, but I can get the area by going second calc, option 7, lower limit 1, upper limit 4. The shaded area is 14.25 units. So if this was a homework question, the answer to part A, that would be an unsimplified version of the answer to part A. That's the integral needed to find the shaded area. And the answer to part B would be 14.25. It's always nicer if you simplify. So down here I did the simplification. I put both functions in a parentheses. It's not necessary ever to put the first function in a parentheses. And the second function needs to be in a parentheses if it has more than one term. So there's my first function, top function minus the bottom function. And then I cleared the parentheses and wrote the problems a little bit differently. I wrote this x as a 1x, and this minus x over 2, I thought of it as a half x, because that would simplify to x over 2. And when I cleared the parentheses, the minus attached to the 3, and the minus changed to a plus on the x. And then the 4 minus 3 part was a plus 1, and then a 1 plus 1 half. I could just do that on my calculator if I'm not wanting to deal with fractions. 1 plus 1 half, math, enter, enter. That gives me my 3 halves x. This would be a better answer for part A. The function needed to compute the area is the integral from 1 to 4 of 3 halves x plus 1 dx. That's a better answer, but there's a danger when you're simplifying. If you simplify and you simplify it wrong, it'll make part B wrong because you won't have something equal to the correct function, and part A will be wrong because you simplified wrong. So if you don't simplify, I'll live with it. There's one twist to this, and the twist to this is if the graphs cross in the shaded area. And another image I stole from Google because I liked it better. So if I want to find this, there's two functions. There's this function here that at first it's on the bottom of the two functions, and then after it crosses, it winds up on the top. So I'm going to need to find two separate integrals. In this function, the first function that starts on the bottom and ends on the top, that font can't show up with my .chem. It doesn't have enough resolution to make that show up. That function that in the first region starts on the bottom, ends on the top, is y equals x squared plus 3x. And in the first region, it goes from x equal to -2 to x equals 0. In the second region, it goes from 0 to 1. I'm going to have to calculate two separate integrals to get the area. So for part A, to find the area, the integral to get the area, it's actually going to be find the integrals to get the area. One integral is going to go from -2 to 0, and the other integral is going to go from 1 to 0. In order to figure out in each shaded region what I have to subtract, because it's always a subtraction, top minus bottom, I need to know the other function. And the other function is 2x cubed minus x squared minus 5x. So that other function in this region, it's the top. And that function is y equals to 2x cubed minus x squared plus 5x. And then in the second region, it flip-flops and becomes the bottom. So this y equals 2x cubed minus x squared plus 5x. It's either a top or a bottom depending on what region you're integrating. So let me do part A. Part A, I'm going to need two separate integrals to get the area because the functions flip-flop. The first integral, I'm going to do both functions in a parentheses separated by a dx. So top function in the first integral is going to be this 2x cubed minus x squared plus 5x. And in the first region between -2 and 0, the bottom function is x squared plus 3x. That integral by itself will give me the purplish pink area. In the blue area, I need to do subtraction to find my integrals. Top function in the blue area is the x squared plus 3x. I didn't leave myself enough room, but I'm going to scrunch it in here. And the bottom function is the 2x cubed minus x squared plus 5x. I'm competent entering this on my calculator. I'm going to call this my answer for A. The integrals needed to find the shaded area. I need one integral to find the pink area, another integral to find the blue area, and maybe put a big plus sign because the areas need to be added. I'm going to get this area and then that area and add them together. So that's my answer for part A. For part B, I'm just going to press buttons mindlessly on my calculator to get these. I don't want to integrate those by hands forever. So first one, just be safe, use my parentheses. So 2x cubed minus x squared plus 5x minus x squared plus 3x. Don't need any of the dx's on my calculator. I just put the top function in a parentheses, the bottom function in a parentheses, separated them by a minus, and now I'm going to integrate from -2 to 0. So second calc, integrate. The picture will look nothing like the graph when you do the subtracting. It distorts everything, but I'll deal with it. Lower limit -2, upper limit 0. And you should not get negative. If you get negative, you've made a mistake. Y equals 2x cubed minus x squared plus 5x. Oh, no, that's right. Let me double check what I have here. I don't know what I've done wrong. I'm going to completely erase this and make sure that this first integral, 2x cubed minus x squared minus 5x, and then minus x squared plus 3x. I should get 2.67 for this, but I did it earlier. That means I entered something wrong on my calculator. You should never get a negative area when you're doing top minus bottom. So let me try again. 2x cubed minus x squared plus 5x, close my parentheses, minus parentheses x squared plus 3x, and graph it. It's the same graph. Something is happening. It's not going to work. Second calc, value, -2 to 0. I don't know. 2x cubed minus x squared minus... Oh, there's my mistake. Look at this. I have a plus 5x there. It's supposed to be a minus 5x. Just this little stupid mistake. There's a minus 5x and I wrote a plus. That silly little mistake is killing me. So if I come back here now and change this to a minus 5x, let's hope that's all I entered wrong. If you get a negative, you know you've entered it wrong. And so this should, it's just because I can't read the font is my issue here. That was supposed to be a minus. This is supposed to be a minus. Ugh. Graph it. That's much better. Now the graph is above the x-axis. So second calc. sorry, and negative 2 to 0. The first region is 2.67, rounded to 2 decimals. Let me do the second region. This function x squared plus 3x minus this function 2x cubed minus x squared minus 5x. Apparently I need stronger reading glasses for that font, and I just didn't pick that up properly. So let me do the second one now. Y equals clear. X squared plus 3x is the top function, minus parentheses 2x cubed minus x squared minus 5x. The graph gets distorted when you subtract, but still can get the right answer. Now I'm going to integrate from 0 to 1 for this one. So second calc integral, start at 0, end at 1. My second one comes out to, I'll round it to 4.17. So to get the total shaded area, I found this shaded area by subtracting the two integrals, fixing my sign error, going between negative 2 and 0, top minus bottom. To get that area, top minus bottom, between 0 and 1, I get two areas. The left one is 2.67, the right one is 4.17. When I add those, that's the combined shaded area. Let's jump into the homework now. I think this is enough theory. And in this section, we're only going to use our calculator for integrals. The important part is just being able to understand what you need to integrate. So problem 1 and problem 2 are essentially twins. They give us a graph that's shaded, and they tell us which functions make up the graph. So in problem number 2, which I'm going to do, the shaded area, if I look at it, it goes between x equal to negative 2 and x equal to positive 2. So when I go to do part A, to calculate the integral to show the shaded area, I need to know the edges in terms of x of the shaded area. And this goes from x equal to negative 2 to x equal to positive 2. So my integral is going to go from negative 2 to 2, and I'm going to subtract the function that's higher, which is the dashed line. In this case, the dashed line is f of x equal to 6. So I'm going to do the higher function minus the lower function, and the lower function is the parabola. So for this particular graph, the f of x equal to 6 is the top function, and the g of x equals x squared plus 2 is the bottom function. So for my answer to part A, I'm going to write that. The second function should always go in a parentheses. The first function doesn't ever need a parentheses. I could simplify this that would be preferred, but it's dangerous right now. I'm not feeling mathematically that comfortable right now for whatever reason. I'm not perfectly awake. But if you simplified that and got that, that would be a better answer. But both of these will give the same area. And let me find the area now. Calculator only for this section. As long as you can get the integral set up right, I'm okay for this very last section of the semester just to do the integrals by hand. We're going to do plenty of integrals on the test. I know that you could do these if you had to, and a lot of these, they're going to have fractions, and I just didn't want to get into it. So let me integrate from negative 2 to 2. And the answer is going to be 10 point rounded to 2 decimals, 6.7. So this answer for part A, completely fine. Simplified version of it, also completely fine. I don't think the font's going to be big enough on problem 3 for you to pull it off the screen, but if you can, there it is. I'm going to move on to problem 4. And on problem 4, I'm going to figure out where I'm integrating from. It looks like I'm integrating from negative 3 to positive 3. So when I go to do part A, to create the integral needed, I need to integrate from negative 3 to positive 3. And if I look at the graph, the dashed line is on top, and the dashed line is negative x squared plus 18. So when I go to do my answer to part A, the negative x squared plus 18 is going to go first. I can put it in a parentheses, but I don't have to. And then the function that's going to go second is the solid one, and the solid one is the g of x equals to x squared. So I'm going to subtract these, and I don't need a parentheses when the g of x is a monomial. If it's a binomial or more, I need parentheses, but because it's a monomial, I don't need. And I'm going to tack on a dx. Usually you put a big parentheses separating everything from the dx, but not such a big deal. If I wanted to simplify this, this is negative 1x squared plus 18 minus 1x squared. This is going to give me negative 2x squared plus 18. And now let me integrate it to get the numerical answer. Again, for all calculator for this section is going to be fine. Everything else on the test is going to wind up being a by hand integral. So there's the function without doing any subtracting, just in case I mess up on my subtracting. It's safer entering this, to be honest with you. That way you're going to be at least guaranteed. Well, you can't even type it right. You're not doing well. I used the wrong minus. I used the minus on the bottom row of the calculator as opposed to, I used the negative as opposed to the minus. And I'm going to integrate from negative 3 to 3. Negative 3 to 3. The answer to part B is going to be 72. So this would be fine for part A. Simplified would be better for part A, but I'll live with an unsimplified version for this. Let's jump to one where they crisscross. And your problem 7 is a crisscrosser. Again, I don't think that's going to show up well enough. I didn't plan on doing your number 7, but I think my problem should show up well enough. I have two areas here because the graphs crisscross. The first area goes from the origin, which has an x coordinate of 0, to where they cross, which has an x coordinate of 1. So when I go to do part A, one of my integrals is going to need to go from 0 to 1. And then the second portion here goes from x equal to 1 and it bops out at x equal to 2. So the next one's going to need to go from 1 to 2. I'm just going to subtract the functions inside the integrals and put a plus sign between them. I'm going to add the two areas. So the first graph, this dash function is on top, and the dash function is the square root of x. So for the first one, I'm going to do the square root of x minus x cubed. Maybe tack on a dx and put the whole thing in a parentheses. That would be nice. Once we get past the intersection, then the solid function is the higher function, and the solid function is the x cubed. So for the second region, I'm going to go x cubed minus square root of x, pop a parentheses in, pop a dx in. This is a perfect answer for part A, and those don't even simplify. That's the best I could do for part A. For part B, I'm going to do one at a time and get each integral separately. So the first integral in part A, into my y1, I do second and x squared for a square root of x. My calculator makes me put a parentheses in. If you have a newer calculator, the keystrokes might look a little bit different. So that's the function, and now I'm going to integrate it, starting at 0, ending at 1. Starting at 0, ending at 1. And I'm rounding to 2 decimals. My first region has an area, I'm going to say, of 0.42, rounding that to 2 decimals. Now I need to put a new function in. My new function for the second one is going to be x cubed minus the square root of x. And I'm going to integrate that from 1 to 2. Start at 1, end at 2. So the second one, rounded, is 2.53. So the total shaded area, and my answer to part B is going to be what you get when you add these. And I added them to make sure I wasn't filling up my videos with a bunch of errors. is 0.42 plus 2.53, or 2.95. So let's pause and do a part 2. And in part 2, we're not going to be given the graph, and we're going to have to create the graph, and it's just going to be a few problems. So problems 1 through 10, the graph is given to you. Either the graphs have 2 distinct regions and you have to calculate them separately, or just one and you can do it with one integral. And completely permitted to use your calculator to find the integrals. You just have to be able to set them up and tell me what you're integrating. This is where the bulk of the points are going to come in. In this part, that's just button pressing. Or we could do it by hand. None of the integrals that I did in this video would be ridiculous to do by hand. But it's the very last section of the semester, so I thought we'd cut you a break.